Welcome back to Remote Explorations, guys. It's me, Sinjan, again, and as promised, I'm bringing you probably the last part of ISI's UG and UGB solutions, where I solved the UGB questions. Like I solved all the questions except question 7, which again I unfortunately couldn't solve. बहुत सोचा था मैंने क्वेश्चन को लेके बट नहीं आया है. Obviously, the questions which I haven't solved will be coming out in a separate video later after some days, क्योंकि कल से हो सकता है मैं मोस्ट प्रोबेबली CMI का पेपर का सॉल्यूशंस शुरू करूँगा. एक्चुअली शुरू कर चुका कल से. मोस्ट प्रोबेबली वीडियोस अपलोड होने भी लगेंगी. तो ये इफ़ यू वांट मोर सच कंटेंट, डू लाइक, शेयर एंड सब्सक्राइब टू रिमोट एक्सप्लोरेशंस. एज ऑफ एग्ज़ाम्स अपना नेक्स्ट टारगेट एग्ज़ाम तो नाइजर है ही है. उसको छोड़ के मेरे कॉलेज का भी एग्ज़ाम है. IIMA का भी एंट्रेंस एग्जामिनेशन है, विच यू कैन चेक आउट एट IIMAodisha.ac.in के ऑफिशियल वेबसाइट में. सो उसका एग्ज़ाम इज़ ऑन 28th June. इट्स अ फुल मल्टीपल चॉइस पेपर. 45 to 50 क्वेश्चंस रहता है, ईच 2 marks. काफ़ी अच्छा वेरिएशंस रहते हैं क्वेश्चंस के. लाइक क्वेश्चंस आर फ्रॉम ऑल द टॉपिक्स. ऐसा नहीं कि कुछ ही टॉपिक्स में कंसंट्रेटेड रहते हैं. सो या डू गुड, चेक इट आउट. अच्छा इंस्टीट्यूट है if you want to have a career in mathematics, future in mathematics or computer science. So before I go on with this, मैं तो मुझे बहुत लोग पूछ रहे थे कि सर इज़ IIT JEE, लाइक ऑब्वियसली एक यूजुअल ट्रेंड है ऑफ IIT JEE एंड नीट. सो मुझे लोग पूछ रहे थे IIT JEE इज़ absolutely necessary for doing research in mathematics, but yeah, it's never like that. It's not like that. उसके ऊपर मैं आज रात को मोस्ट ऑफ एक वीडियो लाने वाला हूँ. लाइक आई विल बस्टिंग द myth of IIT JEE being the only way for doing higher research and higher studies in mathematics. So yeah, वैसा बिल्कुल नहीं है. We have colleges, we have institutes which are much better than IIT JEE, like than the IITs and the NITs for doing research and abroad, going abroad and doing research, higher studies. Yeah, that is a different topic. So do stay tuned for that video. 9 से 10 मिनट के अराउंड वीडियो होगा. That will be coming up at night today. So let's get started. मैंने अपने इसके पहले वीडियो में क्वेश्चन 1 and 2 को सॉल्व किया था. सो नाउ स्टार्टिंग विद क्वेश्चन 5. What are we given here? And I will be checking out the highlighter ones. Yeah. What do we given? 1 by A plus 1 by B plus 1 by C equals 1 by A plus B plus C. And we need to show for any odd integer k, 1 by A to the power k plus 1 by B to the power k plus 1 by C to the power k equals 1 by A to the power k plus B to the power k plus C to the power k. Okay. A very standard result. People who have done questions from excursion and everything, they must know the result. A very standard result. How do we go for it? So ये तो हमारा दिया हुआ है. What do? We bring this A plus B plus C to this side and simplify this. Ultimately ऐसे सिंप्लीफाई करते हैं ताकि this thing comes B by A plus C by A plus A by B plus C by B plus A by C plus B by C equals -2. Symmetry rules, you can very well see symmetry follow हो रही है. So now what do? We substitute the terms. Let x equals to 1 by A, y is equals to 1 by B and z is equals to 1 by C. तो यहाँ से x plus y plus z क्या होगा? 1 by A plus B plus C from the question जो दिया हुआ है अपने यहाँ पे क्वेश्चन में. So 1 by A plus 1 by B plus 1 by C equals 1 by A plus B plus C, and that is what I have written up here, is equals to 1 by x plus 1 by y plus 1 by z, just substituting the values. Ultimately करके क्या आ जाएगा यहाँ पे? what we are getting is the reciprocal identity. So this इसका एक प्रूफ होता है. नाइस लाइक digressed proof is there for reciprocal identity. x plus y plus z into xy plus yz plus zx equals xyz. मैं वो प्रूफ अपने कोर्स में करवाऊंगा, which will be starting very soon. So yeah, for now just keep learning the result. So अब क्या हमें प्रूफ करना है? We need to prove this thing. Cool. सेम सब्स्टिट्यूशन को यूज करते हैं. x equals to 1 by a, that means a is equals to 1 by x, so a to the power k equals 1 by x to the power k. Then ultimately x to the power k equals 1 by a to the power k, y to the power k equals 1 by b to the power k, and z to the power k equals 1 by c to the power k. Like the previous result, again use this and this. Ultimately ये यहाँ पे क्या आ गया है? You can see that we are getting another reciprocal mean identity. Just what is the difference, what is the catch? All the individual terms are raised to the kth power. So what does it show to me then? It works for odd but not. We are getting the same result, which means the result is true obviously. Otherwise same results नहीं आते यहाँ पे. Like इनिशियली जो हमारे पास रिजल्ट दिया हुआ है, इनिशियली जो थिंग इज गिवन इन द क्वेश्चन, उसी को हम लोग ने एक हद तक सॉल्व किया. वी नाउ आर ट्राइंग टू शो that the thing which is given in the question or which has been told to find out in the question is true after we have solved it to that level. Now अभी बात रह जाते हैं यहाँ पे k की. So yeah, this works for only odd case since very easy thing. अभी sign changes when my power stays even, क्योंकि साइन प्रिजर्व नहीं होती है, क्योंकि नेगेटिव का पावर के इवन के लूँगा तो वो पॉजिटिव बन जाती है, और पॉजिटिव का भी पावर इवन के लूँगा तो दैट ऑल्सो बिकम्स पॉजिटिव. सो या माई साइन चेंजेस व्हाइल टेकिंग पॉजिटिव, बट इफ आई टेक इट टू बी ऑड, इफ आई टेक इट टू बी k as odd, then minus का power odd remains minus and minus, and positive का power odd also remains plus. So we do not have any fallacy in sign, and hence the sign is preserved in negative. Therefore it works only for negatives, not for positive, or sorry, it works only for odds and not for evens. Cool. Take 2 minutes to understand. Easy सा question था. Done. Okay. Next question is question number 3. Good question again. ठीक ठाक सही question था. I won't be saying this as to be a tough question. So f is belonging from 0 to 1 to real is differentiable with f of 0 equals 0. ये information हमारे पास दिया है. If my mod of f dash of x is lesser than equal to f of x for x lying between closed 0 to 1, show that f of x is 0 for all x. Cool. Let's get started. Since f is differentiable, g is a Lipschitz function. You all must be knowing the definition of Lipschitz function. So function and is almost everywhere differentiable. So what do? We take a random function e to the power minus x into f of x. हम लोग ये रैंडम फंक्शन इसलिए लेते हैं क्योंकि वी आरंट स्पेसिफाइड कि f of x is what function. So we basically take h of x to be a function in terms of f of x such that h of x equals e to the power minus x into f of x. If I differentiate the function, what do I get? H dash of x equals the normal differentiation e to the power minus x into f dash of x minus f of x. So this thing remains always positive quantity क्योंकि ये तो positive होना ही है, and this thing is always going to be positive. Also क्या दिया है यहाँ पे? Mod of f dash of x is lesser than equal to f of x. So basically f dash of x minus f of x has to be lesser than equal to 0 if we remove the mods. Cool. So h dash of x is lesser than equal to 0. But what are we seeing here? My h of 0 is 0 and h of x is lesser than h of 0 is 0. Cool. And this function decreases between 0 to 1. Since this is positive and this is negative quantity, so this is a decreasing function between 0 to 1. What are we getting here with? So hx is equals to e to the power minus x into f of x lesser than equal to 0. That means my f of x is lesser than equal to 0. Cool. And now we follow the same process while dealing with negative of f of x, क्योंकि हमारे पास ultimately we need to show the modular case क्योंकि mod से question दिया गया है. So if we follow the same thing, हमें यहाँ पे क्या मिलता है? f of x is greater than equal to 0 and यहाँ पे क्या है? f of x is lesser than equal to 0. Same process मैंने और दोबारा नहीं किया है. You can continue, you can actually do this process again to show this thing. So now if a function is lesser than equal to 0 and greater than equal to 0 both at the same time, then we are left with only one case, that is f of x has to be 0 for all x is an element of 0 to 1. Cool. Fair enough. Yeah, so now question 7th, a very damn interesting question. I have kept this for later. मैं सोच रहा हूँ solutions क्योंकि मेरे दिमाग में honestly अभी तक नहीं है इसका solution. Good question, probably the best question of the paper, no doubt about that. So yeah, I'm keeping this for later. Now ये क्वेश्चन ये बहुत नॉमिनल सा इंडक्शन रिलेटेड प्रूफ है. यू ऑल मस्ट बी नोइंग द प्रूफ. एएमजीएम इनइक्वालिटी से आता है, बट स्टिल एक बार मैं समझा दे रहा हूँ. इजी सा क्वेश्चन है ये. So what have we given for n greater than equal to 2? My a1 is lesser than equal to a2 lesser than equal to a3 is all the way till lesser than equal to an by positive integers such that my summation ai is sigma ai is basically pi ai. So basically my summation is equal to the product all the way till an. Now what we need to do, we need to prove that my summation is lesser than equal to 2n, and also we need to check when the equality holds. Like it is always जनरली छोटा होता है बट इक्वल कब होती है. सो या लेट्स गेट स्टार्टेड. ये चीज़ क्या है, ये हमारे पास दिया हुआ है. सो व्हाट डू वी डू हियर, वी राइट दिस and denote this as s equals to p. We what we need to prove, s is less than equal to 2n. Because we try to see equality. जब हम लोग यहाँ पे equality देखेंगे, मतलब चेकिंग आउट कि एस और पी कहाँ कहाँ पे इक्वल हो रही है, वो विल सी कि 2 फॉर n equals to 2 and 1 2 3 for n equals to 3. Similarly for n equals to 4 equality. Now we try to prove the general equality by AMGM. क्या करते हैं, a1 what do we know by AMGM? AM is greater than equal to GM, so a1 plus a2 all the way till an by n is greater than equal to a1 into a2 all the way till an whole to the power 1 by n. Now summation ai is pi ai, so s equals to p. That means s by n is greater than equal to s to the power 1 by n. I am taking that to be p. तो यहाँ पे क्या हो रहा है, वंस वी यूज द एमजीएम इक्वलिटी, यू सी यू आर गेटिंग स्टक एट दिस पोजीशन. इसके आगे हम लोग कुछ कर ही नहीं पा रहे. बट अभी इंडक्शन यूज करूंगा तो थोड़ा इंट्यूटिव है. यू नीड टू थिंक ऑफ दिस अ लिटिल व्हेन यू सी द वीडियो, बट ठीक से है आई शुड से. ये चीज हमारे पास दिया हुआ है एंड समेशन इज गोइंग टू बी पाई. देन समेशन ऑफ a लेस देन 2 इक्वालिटी होल्ड्स इफ मल्टी सेट इज ट्रू फॉर सम स्पेसिफिक वैल्यू. सो दिस इज माय मल्टी सेट. अभी यहाँ पे अगर हम लोग वैल्यूज चेक करें, सो दिस इज व्हाट यू आर गेटिंग लाइक व्हेन यू ट्राई टू फाइंड आउट व्हेन द इक्वलिटी एग्जिस्ट. नाउ ईच ऑफ दिस ओबे द पैटर्न. इसका मैंने इंडक्शन वाला एकदम रिगोरस इंडक्शन प्रूफ नहीं किया है बिकॉज आई नो दिस थिंग. तुम लोग को भी जानना चाहिए. इफ नॉट यू कैन कमेंट मी, आई विल बी शोइंग यू हाउ टू डू द रिगोरस इंडक्शन थिंग. सो बेसिकली द पैटर्न जो आती है दैट इज नंबर ऑफ वंस प्लस स्मॉल नंबर्स in such a way that my summation equals to pi equals to 2n. Only cases to hold inequality is this. थोड़ा सा क्रिटिकल हो सकता है समझने के लिए. चेक इट आउट वंस मोर. लास्ट वाला पार्ट अच्छे से देखो. Cool. Probably this is my last question, I guess. Yeah. ये फोर्थ वाला मैंने सिर्फ लॉजिक बताया. I haven't solved the full thing. So my sixth is let n be the set of naturals and let ai comma bi be bijection of n cross n, where my I is lying between 1 to 9, be 9 distinct tuples, where my s is 2 to the power ai into 3 to the power bi, to show 3 distinct elements of s whose product is a perfect cube. Okay, s must be of the form of 2 to the power ai into 3 to the power bi. हमने 3 एलिमेंट पे 2 to the power ai into 3 to the power bi, 2 to the power aj into 3 to the power bj, and 2 to the power ak into 3 to the power bk. Cool. तो बेसिकली जब मैं प्रोडक्ट करूँगा इन तीनों नंबर्स का, सो व्हाट विल आई बी गेटिंग टू द पावर ai प्लस aj प्लस ak टू द पावर bi प्लस bj प्लस bk. इट्स अ परफेक्ट क्यूब व्हेन ai प्लस aj प्लस ak is congruent to 0 mod 3, bi प्लस bj प्लस bk is congruent to 0 mod 3. a little different approach, modulo and pigeonhole principle के approach करके यहाँ पे है. So what we do, we define each AI comma BI modulo 3, that is AI modulo 3 comma BI modulo 3 as a subset of, or probably as an element of this bijection. Now what is this bijection? Possible sets of remainders when divided by 3. Now when you divide a number by 3, what do you get? You never get a remainder 3. Either you get a remainder 0, that is fully divisible, or you get a remainder of 1, or you get a remainder of 2. Cool? Yeah. So this bijection is basically 3 into 3. So basically we get possible residual pairs of mod 3 to be 9. So 9 possible residual pairs of mod 3. Now key factor to be used, we go into vectors. थोड़ा सा अलग है ये. We go into vectors. We consider vectors in F3, that is my 3-dimensional space, and want to choose 3 such vectors, mod 3 tuples, whose sum is 0, 0. Cool. Exponents of 2 and 3 will be both divisible by 3, product a perfect cube. Now claim among any 9 elements in F cube, all of them are distinct. There exists 3 whose sum is 0, 0 mod 3. So by combinatorics and geometry, or probably by combinatorial geometry, that would be a better term. So my F3 square is basically a group with 9 elements is in a 2D vector space. So any 3 element subset of F3 square that adds to 0 corresponds to a line in the plane over F3, and we have got 12 such lines. So ठीक से सोचो इस चीज़ को अच्छे से. F3 basically group with 9 elements in a 2D vector space. Excuse me. So any 3 element subset of F3 square that adds to 0 corresponds to a line in the plane over F3. Now we have got 12 such lines, 3 into 4. So in a set of 9 distinct tuples in F3 square, some triples must form a line, that is the summation must be 0. So my result is basically any 9 distinct vectors in F3 square contain at least 3 summing to 0, 0. This was my claim and I proved it. Now proving is basically done by PHP, and that is applied up here. Think about this, nice problem. Cool. Now question number 4 is something which I had told you the logic about when I was probably doing number theory, I guess. So I want you guys to try it. ठीक ठाक सा problem. I won't say too easy, I won't say too tough. Nice problem. So do go try it. Whatever happens, if it happens, then very well, ping me down in the comment section. और नहीं होता है, then please say. I will be solving this too in a separate video. No problem with that. So yeah, I hope other solutions except question number 4 and question number 7 are clear to you. Nice paper UGB. Not so tough, not so easy. Moderate सा paper था. At least we could get 3 to 4 correct. If I leave 2 to 3 questions completely unattended, 3 तो correct होना ही चाहिए था, no doubt about that. So yeah, that's it for today, guys. I'll be coming up at night with a myth busting video. So do stay tuned for that. And till then, bye bye. Take care. Do like, share, and subscribe to Remo's Inspirations.